We're ready here, guys. Okay. So, got everything set up here. Good. Okay. Um, so everybody got the scatter plot here with this? I'm going to split my screen here on my iPad so I can pull up the data too and look at the data while I do my plot. And I'll get our graph going here. You can check it with mine, see what you think. All right. So on the x-axis, we're going to title that one number of absences. Okay. Try that again. That was a little. There we go. Okay. And then on the y-axis, semester one grade. I told you in the directions, if you wanted to, you may use a break. Okay. And you're more than welcome to use a break if you want to. Okay. So I don't think that's necessary, though, on the x-axis because you have only integer absences. There's no reason in the biggest is 10. We have 10 spots, so that's going to work out just fine. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we can discuss for a minute about the y-axis. Anybody want to tell me how they scaled their y-axis here? What did you guys decide to do? Anybody want to volunteer that information to me? What did you decide to do? Did you use a break? Did anybody use a break? Show me a hand if you used the break. Maddox used the break. So what was your lowest value after your break? 65. Okay. So you just went, and then how did you count the rest? Everybody, you went up 5 each time? Okay. Did anybody start at 0 and go by tens? Anybody go that direction with their scale? That's also a possibility. Okay. Either one would be correct. Again, I'm not going to count off if your scale is different from my answer key. What I'll count off for is if your scale is not consistent. Okay. So each mark on your scale has to represent the same amount of space, the same amount of distance from the previous mark. Okay. So each mark has to represent 10 or 2 or 5 or 3 or whatever your scale might be on your assessment. All right. You also need to pay attention to the directions on the assessment. If the directions say do not use a break, I will count off if you use a break. Okay. But if it doesn't say anything about a break, then you're more than welcome to use one. If it says breaks are allowed, then you're more than welcome to use one. Okay. All right. So I'm going to go with what Maddox did. I'm going to use a break here on mine. We're going to go right here. I'll break that off. Start with 65, 70, 75, 80, 85, 90, 95, 100. I'm going to stop at 100. So far, so good, everybody? Show me a thumb. Everybody okay with that? Very good. Very good. All right. Start plotting points. Okay, I have 0, 95, so I have a point right here. Okay. And then 388 is approximately here. Okay. And then 290, right about there. 583. 779, 970, 485, 194, 1065, 875. All right, that's my plot. How does yours look? Does it look pretty close to mine? Is everybody okay with that? All right, I'm going to get it real big now so we don't need to use the data set anymore. So I'm going to scroll it over and we'll get it real big here. There we go. Okay. All right. So, anybody want to try to describe the association of the data for the scatter plot? What does the scatter plot show us regarding our data here? Abby, what's it say? Okay. So the overall trend of the data or correlation could be the more absences the student has, the lower their semester one grade. That makes sense. Okay, very good. What about those descriptors we learned about on Wednesday? Remember the one about direction? Okay. Is this association, can we determine if it's a positive or negative association? Abram? Abram says negative. Who agrees? Okay? And can you determine if it's by form a linear or nonlinear association? Anybody want to take that one? Perry? Linear? What do you guys think? Good. Yeah, I agree with that. One of the things, I don't know if I did this for you guys in this class or not, but one of the things that I did yesterday a lot was I added some parallel guidelines to kind of help us figure some of this stuff out. Okay? So, for example, remember, linear for this purpose, for association, doesn't mean that all the points are on what it means is they all follow a linear path or trajectory. Okay? So, one of the things that I've been doing is I've been drawing some parallel lines here. And what we've been saying here is, do all the points, let me try that one more time, do all the points kind of follow those guidelines or within those guidelines? If they are, then you have a linear path. Okay, does that make sense with everybody? Yeah, okay, good. So what we're going to do today in a minute, we're going to go to our scatter plot that we started on Wednesday, okay? And everybody shared their deepest, darkest sleep, their sleep information to me, okay? Oh, Addie, you missed it, okay? Everybody told me how many hours of sleep they got that night, the night before. Oh, boy, I love it. Okay, and so then we used that information, we created a scatter plot, which you're going to see in a second, and we discussed the overall association of that data. And then today we're going to identify some other aspects of our plot and try to get some analysis taken care of, okay? So I'm going to reset for my next class here real quick, and then we'll pull up that scatter plot, and we'll be off. All right, so that's done. We'll go here. Excuse me. And your guys' scatter plot is here. Does that look familiar? It should. Okay. And we discussed that this also has a negative linear relationship. I could draw some guidelines on this too, right? And seeing that how on this graph that the x-axis is in half-hour increments, where the majority of our classes, I think yours was only one, the other classes had their increments in whole hours, okay? So by having it in half-hour increments, it spread the data out a little bit more horizontally, okay? So it's not as condensed. So even though that's the case, these are small increments of time here, and this shows that this data does kind of follow a linear pattern. We kind of proved that with a couple of the other students or classes graphs. Like for example, I can show you another one from yesterday, or from Wednesday. There's that example there. There's this example here. See, that's more of a negative linear relationship too. Okay. And then there's also this example here. That one's definitely a negative linear relationship, right? I mean, you can definitely tell it on that one. Okay, that's seventh periods from Westhouse. Okay, so they're all saying the same thing. They're all saying that according to our data that we have as a team, that a student who goes to sleep later on in the day or evening or night gets less hours of sleep. Okay, and that makes perfect sense. All right, so now what we're going to do is we're going to the increments are so small, but that's okay. I'll show you some examples of these from some of the other graphs, and we'll be able to relate a little bit. All right, we're talking about clusters, outliers, and gaps. Okay, so I want to discuss these terms with you guys. A cluster is a set of points, a small group. Now, that word small is proportional to how many points are in your data set. Okay, we have a very small amount of data points. So for us, a cluster would be a group of like 2, 3, or 4. Okay, that are just kind of joined together somewhere on your scatter plot. There's just a little teeny tiny group of them somewhere. Okay, and if that's the case, then we identify that as a cluster. All right, so I want you guys to look at your graph here for a minute and determine if you can tell any clusters here. Any clusters you want to identify? Now, here's the thing with these three components: clusters, gaps, and outliers. What we're talking about right now is very subjective, which means that what I think might be considered a cluster might not be what anybody else thinks could be a cluster. It depends on how you argue your stance on it. Okay? If you provide an argument that makes sense, then you could be right, whereas your neighbor could provide the alternate argument and could also be correct. Okay? It's very subjective here. So when you try to make a claim about a cluster or a gap or a possible outlier here, okay, then you need it's not about so much what you're identifying, some more about what your argument is as to why you're identifying it. Does that make sense, everybody? Okay. All right. So does anybody want to venture a contention here that there might be any kinds of clusters of order pairs here on your graph? And keep in mind that these are very small increments of time. Okay. Abby? Okay, so we're going to identify these by their x coordinate. Okay, so we can identify them quickly. So, are you saying like this set here or this set here? How much space are we going to allow for this? So from here to here?
Oh, 12.
12 to 1. Okay. All right. What do you guys think? What does everybody else think? Could this be considered a cluster? We have a pretty big gap of no data there between 10:30 and 12, or 11 and 12. That's an hour that's passed without any data. So, I mean, theoretically, if you wanted to consider an hour being a big enough gap, okay, depending on what your take is on it, then you can say that this is a cluster right here because these are all separate by half an hour. Does that make sense? Okay. So then, by that nature, would there be another gap that we could identify on here too? Or not another gap, another cluster? Trevor? That one right there in pink? Okay. So when we're going to list these on item 4, we're going to list them by their order pairs. Okay. We'll just put all the order pairs of the cluster on the line, and that's how we're going to identify them. Does that make sense, everybody? We'll start with the orange one. Start with the orange one here. So for the orange one, we had these points. We'll pull them up here. 12, 8, 12, 7, 1, 6, 12, 37. Okay. So we had 12, 8, 12, 7, 12, 37, and 1, 6. Are we okay with that? And just so we can coordinate here, I'll highlight this in orange again. Yeah, there we go. Again, very subjective here, okay? You might disagree with this, and if you disagree with it, that's fine, okay? You might think those are too far apart, okay? You might think that only these two right here might be a cluster. These two right here, okay? And that's fine too, all right? It's how you describe it. It's how you explain it. That's what's the most important thing here, okay? All right, and the other one here is from 10:30 and 11. So 10:37, 11:06. Okay, everybody good with that? Show me a thumb if we're okay with how to identify clusters. Good. Excellent. Okay, let's go back and look for some gaps. Okay, and this I'm gonna let you guys turn and talk to your group mates. Everybody has a group of 3 today. So turn and talk. See if you guys can decide if there's any gaps in your data. Now, when you decide if there's a gap or not, there are a couple of provisions you have to remember. Okay? Gaps cannot happen before the first ordered pair of data. Okay? So they cannot be before this part right here. Again, I want to circle that blue. That one right there. They cannot be after the final entry. Okay? They have to be between the first and last data points on your plot. Okay? So if there's any gaps, it has to be between those two data points. All right. Turn and talk. See if you guys can identify any data points or gaps. When we do that, we talk about their placement along the x-axis here. So you might say like between 11 and 12, or between 10:30 and 11:30. Okay. That's how we identify them. All right, go for it. Talk about it for a minute. So you guys can come up with any gaps. Remember, gaps are, we read gaps going across horizontally. So, like this is a gap where this area here we get none going vertically. Okay, we can go horizontally, going across. Okay. Okay. Our group's ready to report out. Okay. I'll ask for volunteers. I'm not going to put a man on the spot today. So, anybody have an idea where there might be a potential gap in this data? Sure. So from 9 to 10, so from here to here. Fortunately, this is our first data point, right? Gaps have to happen after that point. 11 to 12. I think that's a very good place. I mean, that's an hour of time without any data. Okay? The other place that we have a potential gap is like from 10 to 10:30, but that's a half an hour. We just identify that as a cluster with the orange cluster, right? So that doesn't necessarily mean that it should be a gap then. So I think the only thing that makes sense here regarding what we've set for our limitations is that space between 11 and 12. Who agrees with me on that? Be okay? So and I'm just going to mark that green. I'm just going to highlight that whole section green from there to there. Okay. We'll go down here and we'll mark it. Oh, I need to put that as a, yep, there we go. So gaps, we said, what was that time again? It was 11 to 12? 11 to 12, okay. There we go, okay. And then finally, last but not least, I want you to look at your graph, talk with the group, see if you can determine any outliers here. Now, an outlier is a single point or data entry, data value, that doesn't fit the overall data pattern, okay? And it really needs to be pretty obvious. So again, I'm going to draw these guidelines for us on our plot to kind of help us model the data association here, okay? And I want you guys to turn and talk and tell me if you think there's any outliers. Are there any data values for our plot that don't really fit the overall data pattern? Okay? It's okay to answer no if that's the case. It's also okay to answer yes if there is one. Go ahead and turn and talk and figure this out, okay? Do you think any of our ordered pairs could be considered an outlier? Go. Show me your thumbs, guys, if you think there's any outliers, yes or no? Yeah, I would agree that with your that probably isn't one. Okay. Even if we were to put a point here close to those guidelines, even really, really close, sometimes you don't even want to consider that also. I mean, you have to determine again what's a good criteria here for an outlier. Okay, something like this right here, that's still pretty close to the guideline. Okay, it needs to be something that's really far fetched, and on your assessment, if there is an outlier, it'll be blatantly obvious. It'll be like in your face obvious that there's an outlier. Okay, so I suggest we put our own on here. I'm going to put a point. Let's see. I'm going to put a point like, how about this? Now, would the point in purple be considered an outlier? Does it fit the overall data pattern? What do you think? That's an outlier. The purple one's an outlier. It's by far doesn't fit anything. A student that went to bed at 9 o'clock, according to our data, should be getting at least 10 plus hours of sleep. This one got 3. That's way out of line. Okay? Does that make sense? So you know what you're looking for if you have to find an outlier? Good. Good. Okay? Excellent. All right. So I'll put it on here to be 9p 3 hours. That's our outlier. Okay. Okay. Everybody okay with that information? Okay. So clusters, gaps, outliers. So we get them if we're okay with all 3 of those things. Good. If you need to go back and make revisions on your assignment from yesterday, you can. You can send it again if you go back and change this. Okay. Not a problem. All right. Here's what we're going to do now. One of the things we can do on a scatter plot is we can add a line that kind of models the best models the data gives us a chance to analyze it even further. Okay? We call this a line of fit. Okay? If we use technology to get this line, called the line of best fit. But for our purposes, we're just going to use it. We're just going to do it by hand. We're just going to estimate where this line goes. Okay? Now, the line should best model the flow of the data, okay, and be pretty much a good indicator of where our data points are, okay, on our plot. I'm going to put graph on your plot some potential lines of fit, okay, and I want you guys to show me by your thumbs if you think it's a good line of fit for your data or not, okay? All right, so here we go here. I'm going to erase these red lines, and the next red line I draw is a potential line of fit. Are you ready? When we do this, we really don't take the outliers in consideration here, okay? You can a little bit, but we really try to just focus on the majority of the data pattern, okay? So how about this line of fit right here? Is that a good indication for our line of fit for this scatter plot? Okay, what do you think? Show me a thumb, yes or no? Maddox was quick to say no. Why do you don't think so, Maddox? It's too low. Okay? It's too low. So what should I do to improve? Raise it up. Okay? I'll raise it up then. How about now? No? Okay. Whoops. Oh, let me get that up. Okay. Let's try something else. What if I did something like this? that look right? Show me a thumb. Does that look right? What do you think? That's in the middle of your data, right? I think that's what Max is trying to say I need to do. Okay. Does that look right, though? What's wrong with it? It's almost vertical. It's not quite. It's almost vertical. Okay. It's not quite vertical. But is it in the flow of our data? No. Okay. So here's the deal with the line of fit. A line of fit needs to pretty much split your data, okay, if it can. The goal is to get about half and half of your data points on each side of the line. It's not always feasible to do so, okay? But to be close, all right? It needs to be pretty close, okay? And if you can, okay, it has to also follow the flow of your data. This splits the data pretty well, but doesn't follow the flow of the data. So we are going to try one more time, okay? I'm thinking something maybe like this. Does that look better? What do you guys think? Does that look better, everybody? Yeah. Gonna do a little adjusting here. There we go. Okay. All right. So go ahead and fit a line of fit on your plot. Okay. This is also sometimes called a trend line. Okay. What we're going to start doing today, okay, we'll get part of this done. And what we're going to finish then on Wednesday next week is we're going to have to write the equation of this line in slope-intercept form. Okay? So this is a little bit of review from the last topic, okay, and how the last topic applies to this topic. So the question is, what two pieces of information do I need in order to write an equation in slope-intercept form? You can remember that for me. Trevor?
Y equals
Mm-hmm. What does M and B represent? M is the what class? So I need that, right? And B is the y-intercept. How can I get the slope from my equation from my line? What can I do to get the slope from my line right now? What do I need? Abby? Well, that's separate. Okay, all I'm focusing on right now is slope. Okay, how can I get the slope of this red line? What information do I need to get the slope of it? Remember what we had to use last time? The last topic. I needed to find two ordered pairs. Okay? I need to find two ordered pairs on this line in order to get the slope of it. It can be any two. Sometimes what will happen is that you'll have a line of fit that goes through a data point. If that's the case, you can use the coordinates of the data point as you try to find the slope. Okay? Other times, you'll be able to find the y-intercept easily because it'll be a point on your y-axis. It'll be visible on your y-axis. You can use that also to find the slope. Okay? Since our y-intercept is above 10 for this line, what we're going to do on Wednesday is I'm going to put this information into a technology program, a technology app, and it's going to generate the scatter plot and the equation of fit using technology, and we'll get the y-intercept that way this time. Okay? On your assessment, your line of fit will be contained on your graph. You'll be able to identify your y-intercept. All right? It'll cross the y-axis on your graph. I promise you. Okay? And I think for the most part, your homework assignment does too. I think the only exception to that is problem 5. In problem 5, I tell you on Canvas, I think you get to use the 0.060 for your y-intercept. Okay? So we're going to go ahead and get a couple of order pairs here. I don't think we're going to get to the point where we're ready to do the slope just yet. But we're going to pick it up then on Wednesday. We'll get the slope, we'll get the y-intercept, we'll get the equation, and then we'll start analyzing what that information is, okay? Any questions? Everybody good with that? All right. For us to be ordered to do this, though, we need to make a modification to our x-axis here. Remember we said this was the time we went to bed, right? Here's the problem, though. After 12:30, I go back to 1 a.m., right? Okay? So my pattern doesn't continue. It's continuous 9, 10, 11, 12, but then 1, it goes back. It cycles back, right? Okay? In order to get accurate ordered pairs, I need for this to continue onward. So instead of this being time to bed, think of this as being time from noon. Okay? 9 hours since noon, 10 hours since noon, 11, 12 hours since noon. This would be how many hours since noon? 13. Okay? So if you needed to use a point there, you need to call that a next coordinate of 13 to get an accurate ordered pair when you're finding slope. Okay? This would be 13.5 if you wanted to use that one. Okay? All right. Find 2 ordered pairs on your line. Any 2. Okay? We're going to find those 2 ordered pairs. We're going to mark them, and we're going to quit for the day. I'm going to use these 2 ordered pairs right here. So I'm going to use the order pairs 10.5 and 9, and I'm going to use 11.5 and 7. Okay? Everybody see how I got those numbers? Good. We'll find the slope on Wednesday. We're going to quit today. All right? Nice work, guys.